All right, 6.2, day number 1, area between curves. All right, what is an integral and how is it connected to area? Well, if I wrote out an integral from a to b of f of x dx, that would find the area between the curve and the x-axis, right, from a to b. But how do we find the actual area if that function dips below the x-axis? Well, how we would do that is we would find the actual distance, right? So the actual is like finding the distance, which we would do the absolute value of f of x dx. All right, so for example 1, it says graph f of x. The graph f of x equals x squared plus 1, and find the area under the curve from -1 up to 2. Alright, so I'd be finding this area here, which I could easily do by going from -1 to 2 of x squared plus 1 dx, which would be x cubed over 3 plus x evaluated from -1 to 2. Alright, so I skipped a little bit of the algebra, but if we evaluate, right, we plug 2 in, you get what I have there in blue, and -1 in, you get what I have there in green, and so we get an area under that curve between the x-axis and that function, between the values x equals -1 over here and x equals 2 over here of 6. Okay, so find the area of the region R bounded by f of x equals that, the segment of the x-axis between -1 and 2 here. So the area that I'm looking for would be between -1 and 2. So that'd be everything up here and everything down here. Oops, I went a little too far. Everything right there. Okay, so a couple different ways you can do this. You could do the integral from -1 to a, where this point right here is a. Ooh, that looks like a 9. How about an a? There we go. Of f of x dx. And then, oh wow, that was amazingly poor. F of x dx. And then I could subtract, right, which would make that area then positive, from a to 2 of f of x dx. Or what you can do is you could go from -1 to 2, the absolute value of f of x dx. Either of those two will get you the right answer. Okay, so let's talk a little bit about the area between two curves. Right? If I found the area, let's call this right here f, and let's call this right here g. If I wanted to find the area between the two curves, I could take the area, well, first what I'd want to do is I'd want to find out whatever this x value is. Let's call it a, and whatever this x value is, let's call it b. Alright, so I'm going to want to do an integral from a to b. And if I found the area under g, I'd get that space. If I found the area under f, I'd get that space. Now the blue space is what I want, so how could I get it? I could take the area from a to b of g of x dx, and then I could subtract the area from a to b of f of x dx. Alright, now could I make that more compact? Absolutely. What you're going to do is you're going to take the upper function and then minus the lower function dx. Alright, so let's look at an example. If I want to find the area of the region bounded by these two, which of those two is the upper function? Well, the upper function would be the linear function. Okay, because what am I looking for? I'm looking for the area between these two curves. So the linear function is the upper function. The quadratic function is the lower function. I need to find out what a and b are. That looks like -2 this looks like positive 3. Algebraically, you could probably figure that out by setting those two functions equal and finding their two solutions. But then I could do this. I could take the integral from negative 2 to 3 of upper function, which is x plus 4, minus lower function, which is x squared minus 2 dx. I could simplify that, which would be negative x squared plus x plus 6 dx. And you can evaluate that. I did it on my calculator and it came out to be about 20.833. Alright, let's find the area between y equals. Alright, so find the area between y equals square root of x and y equals negative x plus 6. Now I want you to kind of tip this on its end for a moment and think of this as the upper function and this as the lower function. But the blue function is now the upper function with respect to x instead of y. So it's the larger the two x values. So think with me for a moment about this. I'm going to go from A to B. I'm going to call A 0 and B whatever this y value is. Okay, so I'm going to go from A to B of this x minus this x. And all of that with respect to x. So the blue x comes directly from this function here, which would mean that x equals 6 minus y. The red x comes from this function here, which means that x would equal y squared. So now I'm just integrating with respect to y instead of x like I did before. Now I need to know what a and b are. Well, a is 0, and b would be where these two are equal. So I'm going to set the square root of x equal to negative x plus 6, which means x equals negative x plus 6 squared. Alright, so x would equal, it looks like if I FOILed that, x squared minus 12x plus 36. So x equals x squared minus 13x plus 36. Whoops, I meant to put a 0 here. Right, I subtracted that over. Okay, so it looks like if I factored that, I'd have x minus 9, x minus 4. So I'm going to take an assumption here and say that this has to be x equals 4. Well, if x equals 4, then y equals 2. So this value here would be a 2. Alright, so I'm going to integrate with respect to y now of 6 minus y minus y squared. And you can plug it right into your calculator just like that. And you should get for your area under the curve to be 7.333. Okay, let's say that just totally blew your mind. You didn't like it at all. Okay, so let me scratch this for a moment. If you didn't like this, you can just you can ignore it, and you can always differentiate this or integrate it with respect to x. So think of it like this. I'm going to integrate from 0 to 4 along the x-axis to find this area A. Right, and I'm just going to take the square root of x dx, right? Because that would be the area underneath that curve down to the x-axis. And then I'm going to add to it from, looks like 4 to, I think it's 6. Yep, this point right here would be 6. Alright, and I'm going to integrate the other function, which would be negative x plus 6 dx, right? So that would be in terms of x. Down here I just realized I had made a mistake. This should be dy. Okay, and if you evaluate this, you will still get the exact same answer. There's just a little bit more to the steps here. You have to integrate twice, but maybe you're willing to do that if you can't visualize this horizontal integration with respect to y. All right, so folks, that is it. That is 6.2, day number 1, area between curves. Just remember, upper function minus lower function will always get you where you need to be.